25 is on trigonometric functions of any angle. So what this means is that we may not have our values on the unit circle. We might just have to draw a sketch of a triangle and use SOHCAHTOA, okay? Those angles may not be the 45, 30, 60, and so on. Okay, so we're going to sketch these out and then we're going to talk about them. So it says let theta be an angle in standard position x, y, with a point on the terminal side of theta. So r is equal to the square root of x squared plus y squared. So the reason is because this distance is x and this distance is y. Let me put the r over here so you can see it better, and that's r. You can relate those three with the Pythagorean theorem. So see how x squared plus y squared equals r squared? So if I solve for r, I get r is equal to the square root of x squared plus y squared, like that. Do you guys see where that comes from? Okay. Theta can be here, but when I find the sine, cosine, and tangent of it, it's kind of like I'm thinking of theta as there. So even though my theta is more than 90 degrees, if I want to talk about like the sine of theta, I'm going to do opposite over hypotenuse like that. Does that make sense? So even though that angle is kind of on the outside, and I'll talk more about that. So I'm going to have opposite over hypotenuse. And then tangent of theta would be adjacent, or opposite over adjacent. So it would be y over x. And cosine would be adjacent over hypotenuse, x over r. Okay, we did this in the unit circle. So do you guys remember in the unit circle when we had like a radius of 1? Let me do one that's not 45 actually. So let's say we had this point right here. That point was negative root 3 over 2 comma 1/2. What was the sine of that angle? It was 1/2, the y value, right? What was the radius of the circle? 1. Do you guys see how it was still the y value divided by r? But in this case, r was equal to 1. Now there was a miniature little triangle drawn in there. But this degree, if I found the degree, it was 150 degrees, right? But the sine of it was 1/2. Does that make sense? All we're worrying about to make it different, like if I talk about the cosine of 150, it's negative root 3 over 2. Do you guys agree? Yeah. How's that different than if I did its angle over here with 30 degrees? Yeah, the sine is just different. Does that make sense? It's still root 3 over 2 comma 1/2, but the cosine would be a positive. So we're going to consider like what quadrant we're in as we're doing this. Okay, so then secant. Secant is the reciprocal of, she just went for it. Secant is the reciprocal of cosine, which is going to be r over x. And cotangent is the reciprocal of tangent, which is x over y. And then cosecant is the reciprocal of sine, which is going to be r over y. Do you guys remember those? So cosecant, if you want to write 1 over sine of theta, you can do that. Secant is 1 over cosine of theta. And cotangent is 1 over tangent of theta, which tangent was sine over cosine, so it's really cosine over sine. Okay, so since r can never be 0, sine and cosine are always defined. However, what radian measures would make tangent and secant undefined? So let's think about it. So even on the unit circle, we can do that. If I want tangent to be undefined, that means that I want sine divided by cosine to be undefined. Which one of those has to be 0 if something's going to be undefined? The denominator, right? So if the denominator is 0, so what theta gives me a 0 on the denominator? When is cosine of an angle equal to 0? Pi over 2 and 3 pi over 2, exactly. So pi over 2 and 3 pi over 2. So then what about cotangent and cosecant? Well, cotangent is cosine over sine because it's the reciprocal of tangent, and cosecant is 1 over sine. So when is sine equal to 0? Yeah, pi and 2 pi, or 0, pi, and 2 pi, right? Exactly. Does that make sense? You guys get that? Okay, so we're going to be sketching these out. So these are not, do you guys see how like negative 4 comma 3, that's not a unit circle value. So every time we have one of these, we're going to draw a triangle. Okay, so let's think about where negative 4 comma 3 is on our Cartesian coordinate plane, like the xy axis. Okay, so everybody sketch out -4, 3. Did you guys get like right there? And then we're going to draw a triangle. That triangle is always going to be attached to the x-axis. So I'm going to drop straight down and over like that. So a lot of people mess that up, and they try to draw the triangle like this. Don't draw it that way. Okay, so you're always kind of connecting, like part of it's along that x-axis. One of the sides is the x-axis. Does that make sense? Do you guys see it? So this distance here is 4. This distance here is 3. But it's not just 4. We went in the negative direction. So I'm going to go ahead and put -4. Do you guys know what the hypotenuse would be then? 5. Good, Ben, because you noticed that it was a 3, 4, 5 triangle. Do you guys see it? If you didn't know that, you could put r down, and you can be like, okay, r squared is equal to 3 squared plus -4 squared. You would get r is equal to 5. So if I'm finding the sine, cosine, and tangent, all I want to do is make sure that my signs are correct. Okay, the y is positive, the x is negative, r is always positive. So maybe write yourself a note. R is always positive. Kind of like a length, a distance. So if I'm finding sine, cosine, and tangent, it doesn't matter that our angle is here, right? That's where theta really is. What we're going to use is as if that the angle is here. Okay, so I'm not necessarily going to draw that in, but I'm going to do, just like if I did sine, cosine, and tangent, I'm going to do sine is opposite over hypotenuse. Okay, so if sine is the opposite over hypotenuse, do you guys see it? What answer? 3/5, exactly. It's the y value divided by the r value, 3/5. Cosine is adjacent over hypotenuse. Well, that's the x value divided by the r value, which is -4/5. And tangent is the y value divided by the x value. So the y value divided by the x value is 3/-4, or -3/4. Those are our 3 values. Does this make sense? You just kind of sketch it out. Okay, and this can be worded in different ways. So this time on number 2, it says sine is equal to 3/5, and theta is in quadrant 2. So let's think about, first of all, where sine could be equal to a positive number. There's 2 locations. What 2 quadrants are possible if sine is equal to a positive number? Quadrant 1 and quadrant 2. Does that make sense? The top, like sine is, the y value is positive. Okay, but this time it's telling us it's in quadrant 2. So if I'm sketching this out, this is my y value, this is my r value, right? So I'm going to go up only a distance of 3. Do you guys know what our x value would be? It would be 4. It's one of those 3, 4, 5s again. If you didn't know, then you can say, well, y is equal to 3 and r is equal to 5, and we relate them with r squared equals x squared plus y squared. So let's do that. R squared is 5 squared equals x squared we don't know plus 3 squared. So we get 25 minus 9 is 16. So x could be plus or minus 4. If it's in quadrant 2, do we need a positive or a negative? Quadrant 2, x is negative, right? So we need a -4. So we go back 1, 2, 3, 4. And then we draw our triangle in. So we have this distance here, and our r. Does that make sense? Let's see how we can sketch it out. So what is the value of cosine then? Yeah, cosine of theta is going to be adjacent over hypotenuse. So look for your adjacent, look for your hypotenuse. Adjacent is -4, hypotenuse is 5. That's our answer, -4/5. Okay. All right, so let's try some more. All right, same idea here. These are the ones the book likes to put on there. So it says, suppose tangent is negative, so -15/8, and sine is negative. Okay, think about what quadrant we're in. If tangent is negative and sine is negative. So let's start with tangent is negative. It would be either quadrant 2 or 4. Not 3 though, because 3 was like any point here would be like negative, negative. Which when you divide negative, negative out, you get a positive, right? Does that make sense? So right now we're in either 2 or 4. So maybe we'll write above 2 or 4. And then sine is negative. What two quadrants are possible there? 3 or 4. So what quadrant do we have to be in? 4. So just kind of sketch out a triangle. It doesn't have to be perfect. And you can kind of put your theta there. You can think, okay, I know my theta is going all the way around, but this is kind of the triangle representation. So our theta is going to equal, so tangent of theta is negative 15 over 8. That's opposite over adjacent. Think about where you put the 15 and where you put the 8. This will be here, this will be here. Which one is negative, the 8 or the 15? The 15. Not just because it says negative 15 over 8. That could have been 15 over negative 8, right? We just have to think about what quadrant we're in. So we have a positive x and negative y. So if we want to find this missing side, we do Pythagorean theorem. So we'll call it r. So I have r squared equals 8 squared plus negative 15 squared. Or you could write r equals the square root of 8 squared plus 15 squared. So I get the square root of 289. Do you guys know what that is? It is 17, yep. And that one's always positive. R is always positive. So we want to find the value of cosine of theta and sine of theta. So cosine is adjacent over hypotenuse. So it's 8 over 17. Sine is opposite over adjacent. Negative 15 over 17. And that's it. Making sense? All right, so some of these don't have triangles associated with it. It's like the triangles have been smushed and they're totally flattened out and it's just a line. Okay, these are the quadrantal angles. I know that's a weird word. I saw eyebrows raised. Quadrantal. It means it separates the 4 quadrants. Okay, so we're going to have 0, pi over 2, pi, and 3 pi over 2. I feel like the easiest way for people to do sine, cosine, tangent on these ones is just use the unit circle, right? So it could go out any distance. We're going to say it goes out a distance of 1. Okay, but really those could have been anything. Like I could call this r comma 0. Mm-hmm. This says sine is negative, so it says y is less than 0.
Oh.
Does that make sense?
Okay, yeah.
Okay, so this could have been r comma 0, 0 comma r, whatever. If you want to make it 1, that's fine though. Okay, that's really kind of the easiest way to think about it. Okay, so if I have the sine, cosine, and tangent of 0. All right, see if you guys can figure those out. What's the sine of 0? 0. What's the cosine of 0? 1. What's the tangent of 0? 0. Did I hear 2? Okay, what's happening here is that if you had made this 0 comma or r comma 0, the sine would be 0 over r. The cosine would be r over r, but it's kind of hard to see that other r. Do you guys agree? That's why I just write it as 1. It's easier to think of that way. And then this would be 0 over r as well. Okay, so we're just going to think of them as 1s when we do this. All right, so how about the next one? So let's do the sine, cosine, and tangent of pi over 2. Okay, what's the sine? Sine is 1, cosine is 0, tangent is sine over cosine, 1 over 0, which is undefined. Doesn't work. right? Do you guys know where I'm getting these numbers? So sine is the y value, cosine is the x value. All right, how about the next one? So if I do sine, cosine, and tangent of pi, sine is 0, cosine is -1, tangent is sine over cosine, 0 over -1, 0. And then the last ones, so sine, cosine, and tangent of 3 pi over 2. So what do you guys think on these ones? Yeah, tangent's going to be undefined. Greta's already over that one. Do you guys see why? Because it's -1 over 0. Sine is -1. Cosine is 0. Okay, and you can check those with your calculator. Your calculator will give you those values. And your calculator will yell at you when it's undefined. It will say, error, domain. All right, so reference angle. Do you guys remember coterminal angles and so on? Reference angles is just the distance between the x-axis and our ray that creates that angle. Okay, so you know how I was telling you you could just write theta there? We're going to write it as theta prime. So if you have 330 degrees, we know that that goes all the way around to this line. But the reference angle is how far it is away from the axis. So how many degrees would it be away from the x-axis? 30. That's it. So if I have -135, can you guys draw a -135? Is it on the 45-degree line there? Yeah, the halfway line. So our reference angle is going to be trapped between the x-axis and that ray. How many degrees? 45. And then 4 pi over 3. 4 pi over 3 is pi over 3 past pi. So what do you mean it's the same one, like this angle here? So it's going to be pi over 3 away from the x line. Okay, all that is it's the angle that creates this right triangle when you trap it. Does it make sense? Okay. I'm going to pause for a second so you guys can go on your break. All right, so it says use a calculator to evaluate each trig function. So that we've kind of done this before. So like cotangent of 415, you just want to draw where 415 degrees is. Okay, 415 is bigger than 360. How much bigger than 360 is it? Yeah.
45.
Ah, bigger. Yeah. Oh, did I skip one? Okay, so, yeah, so evaluate each trig function, so you must know what quadrant the original angle is in. So if I have 16 pi over 3, so that's bigger than 360, bigger than 2 pi, right? So this is where we start thinking about what 16 thirds is as a fraction. How many times does 3 go into 16? 5 times. What's the remainder when I do that?
5 pi.
Yeah, so it's like 5 1/3 pi is what we're thinking of. So we're going to do 5 pi plus another pi over 3. So let's think about where that puts us. So 5 pi would be going around 1 time makes 2 pi, 2 times makes 4 pi, another half time makes 5 pi. So right now we're here for the 5 pi, like on the left side of the unit circle, right? Where's an additional pi over 3? Yeah, it's like right there. Bigger than 210. It's the 240, right? 240 degrees. It's 60 degrees away from the 180 line. So what is the cosine of that? Well, this point is over to the left 1/2, down √3 over 2. So what's the cosine value? -1/2, exactly. So if it's one of those unit circle numbers, that's fine. We're just going to use the unit circle. So if I have cotangent of -570, ooh, -570. So we're going to go 360 around in the negative direction, right? How much more? So if I do 360 plus 180, I get 540. So that would be 540s here, right? That's another 180. How much more? 30. So I'm going to go right here. So that point is negative root 3 over 2 and then up 1/2. So when I talk about cotangent, it's the cosine value divided by the sine value, which ends up being negative root 3. Good, Kinsey. Do you guys see it? Remember how we can just divide by 2, or multiply by 2, multiply by 2. Get rid of those 2's. Okay, cosecant of 11 pi over 4. 11 pi over 4, again, is bigger than 2 pi. So if you need to think of it like a fraction, that's fine. 11 pi over 4, 4 goes in 2 times with a remainder of 3. We have 2 3/4. So we're going to go around 2 pi, and we're going to have another 3 pi over 4. In other words, it's the same as 3 pi over 4. Do you guys see how we can kind of just get rid of the 2 pi? Because we would be going around one full rotation, and then we're starting again. So then 3 pi over 4 puts us over here. That's the point negative root 2 over 2, comma, positive root 2 over 2. So cosecant is 1 over the sine value. Oops, that should be 11 pi over 4, which ends up being 1 over root 2 over 2. Sorry, I'm running out of room. I'm going to go down here. Do you guys know what 1 divided by root 2 over 2 is? So let's do it. So the long way would be to say 1 divided by root 2 over 2 is the same as 1 times 2 over root 2. So we have 2 over root 2, but we don't like that. Multiply by root 2 over root 2. So we get 2 root 2 over 2, which is root 2. This is not like the longest way ever. You know the way I remember it? I remember that root 2 over 2 is the reciprocal of root 2. Because if I did 1 over root 2, do you guys remember the problems we had where we had like 1 over root 2 and we were like, oh, that's not a unit circle value. But then all of a sudden we rationalized it and it was root 2 over 2. Okay, so when you see root 2 over 2, think of it as 1 over root 2. So when you take the reciprocal, it's just root 2. Yeah?
For cosecant and secant problems, can we just take like the reciprocal? So it's like root 2 over 2.
Yeah.
So that's just cosecant. So
Yeah, so if you don't like, so Greta's saying if you don't like that it's 1 over root 2 over 2 and you want to skip to where it's just 2 over root 2, the reciprocal of that, that's fine. Like if you remember 1 over means reciprocal, you can skip some of that. So let's try that on this one. So if I have secant of 13 pi over 4, so let's think about 13 pi over 4. So 13 over 4 is what mixed number? It goes in 3 times with a remainder of 1/4. So where on our unit circle? What quadrant? The third quadrant, exactly. Because 3 pi, 2 pi is 1 time around. 3 pi is another half time around, right? So 3 and 1/4 puts us right there. So that point is negative root 2 over 2 comma negative root 2 over 2. So if we have the reciprocal, so if I have 1 over negative root 2 over 2, gosh, I keep running out of room. I need to give myself more room on these, don't I? So it's 1 over negative root 2 over 2, which Greta was saying, that just means the reciprocal of negative root 2 over 2. It ends up being 2 over negative root 2. What does that end up being? Negative root 2, exactly. Tricky, tricky. All right, and then these ones are calculator ones. I was thinking these were unit circle ones, but if you do 415 degrees, that's actually 55 degrees past 360, right? So this is not a unit circle one, so we're just going to use a calculator. The hard thing about precalculus is we go back and forth between radians and degrees. So in this case, we want to hit mode and make sure we're in degrees. So 415, if I take the cosine of that, I get 0.57, let's do 4 decimals, 36. Oh, sorry, I did cosine. I was thinking cosine. Divided by sine, which is 0.8192. So then I divide those out. Now, the way I would really do this, so let's erase. I would just do cosine. So I do cosine of 415 divided by sine of 415 on my calculator. So cosine of 415 divided by sine of 415. So check and see if you get the same thing. You should get 0.7002. Did you guys get 0.7002? Exactly. So go ahead and try sine of -8. And let's make sure this time we're in. Do you guys see how we don't have a little degree mark? That means it's radians. So we want to make sure we're in radians. And when you try that, sine of -8, what happens? We get negative 0.9894. It's almost -1. Okay, here's what's happening in that problem. You can grab one on my desk. It's like under that tray thing. Okay, so if I have -8 in radians, that means I'm going in this direction. This one was -pi, right? What's pi? Yeah, 3.14 or something, right? So going around like another half turn would be -2 pi. What's 2 pi? 6.28 something, right? Okay, so where's -8? Well, if I do 3 pi over 2, sorry, not 3 pi over 2, 5 pi over 2, if I go more than one rotation and another half turn, this one is -7.8539. That's the radian measure there. Do you guys know what I'm doing? This is like -5 pi over 2 is that. So we're just a little bit past that. We're like somewhere around there. That's what sine of -8 in radians means. So we're finding the y value that goes with that location. Okay, so we're getting ready to do a couple like that in a little bit. All right, secant of pi over 12. So how would I put that? Whoops. Oh, jeez. I can't find my number. What did I have? -0.9894. All right, so is it 1 over sine or 1 over cosine?
1 over sine.
Nope, 1 over cosine. I gave you a second chance even.
Why?
Because the C's and S's go together. That's the way I remember it. It's kind of a dumb way to remember it, but you would think secant and sine would go together, right? And cosecant and cosine. Yeah. I don't know. What do you think on this one? Pi over 12? That one's definitely radians, right? There's no degree mark. If there's no degree mark, it's automatically radians. Yeah. Were you doing it with your unit circle, though?
Oh, yeah.
Yeah. So your head doesn't need to switch between degrees and radians. You guys know between degrees and radians in your head. Your calculator doesn't know. The calculator will not give you the same thing. All right. So we want to do 1 divided by cosine of pi over 12. So remember, I told you guys that it's not that inverse cosine. Like, it's not cosine to the -1. Do you guys remember that? Okay, so make sure you do 1 over cosine of pi over 12. So when we do, we get 1.0353. And cosecant is going to be 1 over, so we're going to do sine of -7 pi over 3. So 1 divided by sine of -7 pi over 3. So I get -1.1547. Did you guys get that? Okay. All right, so last thing. So it says let sine of theta equal 3/5. So sine of theta is going to equal 3/5. Okay, we're going to draw it out. And it says where theta is between pi over 2 and pi. Does anybody have any idea what that is saying? Theta, our angle, is between pi over 2 and pi. It's between 90 and 180, which means that it's in what quadrant? Quadrant 2. That's what we're saying there. So like I've told you before, like math sometimes is like a foreign language. We have to know how to read the foreign language. What that's telling us is it's in quadrant 2. So we sketch out a triangle. And we know that our opposite over hypotenuse is 3/5, right? So what's the adjacent? 4. Good, you guys know your 3, 4, 5s now. All right, so if I want to find cosine of theta is adjacent over hypotenuse. What is wrong with my sketch as it is?
Oh, it's -4.
It needs to be a negative, right? Because I'm in the second quadrant. X is negative, y is positive, right? So my cosine should be negative. It should be negative 4 over 5. And then my tangent of theta is going to be opposite over adjacent, which is 3 over negative 4. So negative 3 over 4. All right, so we know how to do something like that. Do we know how to do something like this one? This is saying cosine is equal to 0.2. Okay, think about what that's saying. Cosine, our x value, is equal to 0.2. There's more than one location on our unit circle where that can happen. So I don't know where 0.2 is, but if I think about my unit circle, here's 1, right? On the far right side, it's not going all the way over to 1. It's just going over a little bit. Right, you guys see it? So it's not going all the way to 1, just going part of the way. So we want to find two angles that make this. This is where we're going to use our inverse cosine to help us. So I'm going to write cosine of theta equals 0.2, and then to solve for theta, I'm going to use that button that's cosine to the negative 1. And my calculator is going to give me an answer. So let's find it. Okay. If I'm in radians, it will give me a radian answer. If I'm in degrees, it will give me degrees. How about you guys do both? Let's do radians and degrees so you guys can see the degree one too. Okay, so in radians, it gave me 1.369. So that's in radians. But if I did it in degrees, I got 78.463 degrees. Okay. That's this angle right here that I drew. 78 point something, right? Can you guys interpret where that radians is? It's less than pi over 2. Pi divided by 2 is 1.57, right? 3.14 divided by 2, 1.57, somewhere around there. We're smaller than that. Okay, but was that the only answer? No, there's two answers. There's two locations where our cosine is positive. Okay, use your thinking caps. Everybody think about this. Your calculator's only giving you one answer. Every single time it's only going to give you one thing. But there's more than one answer to this. Everybody look up here. We want to figure out how to find this one. In radians. Okay. How do I get around there? How can I find this answer using radians? What? Do what with 2 pi? Add it to 2 pi? Well, if I add 2 pi, that puts me back around the top one. You had 1 pi, right? I take my 2 pi and I subtract it out. I go backwards. So I do 2 pi minus that answer. So when I do, I get 4.9137. So 1, 4. Okay, that's this other one. So this first one was 1.369. The second one was 4.914. Okay, 4.914, that's not quite 2 pi, right? Does that make sense? Okay, we're going to try another one. Okay, let secant equal 1.5. Okay, my calculator doesn't have secant. So I want to change this. I want to write cosine of theta is equal to the reciprocal, 1 over 1.5. And 1 divided by 1.5 is 1 divided by 3 over 2, which is 2/3. So 0.6 repeating, or you can write 2/3. Okay, sketch it out. Think about where cosine is equal to 2/3. It's not 1, right? 1 would be all the way over here. That would be cosine equals 1. So it is somewhere in here and somewhere in here, right? Actually, probably even closer to the axis, but we don't have to be very precise with our, we just need to know what quadrants we're in. Yeah?
When you say when cosines equal to 2/3, do you mean radians or like the x
It's in
and y
radians.
point?
Yeah. You can think of it as 2/3 over 1 if you want to do x and y point, right? So it'd be like x over 1. So yeah, it's both. I guess, okay, no, I see what you're saying. Like, it's 2/3 in radians or is 2/3 the x point? 2/3 is the x point.
Okay.
Yeah. We're trying to find the angle, the radian, that makes that true.
Okay.
Okay, so we do theta equals, and we do inverse cosine of 2/3. Make sure you're in radians, because we want 0 to 2 pi. What'd you guys get for your number? 0.841. What that is this distance right here, 0.841. Remember, radians is like an arc length? Okay, what if I want the whole length going around to here? I take it away from 2 pi, right? So to get this other one, oh dang, I keep erasing the wrong things. To get this other one, I do 2 pi minus 0.841. So I get 5.442. Okay. They're not always 2 pi minus, so let's try some other ones. Okay, cosecant is the reciprocal of sine, right? So this is sine of theta equals 1 over negative 0.72. This gives me sine of theta equals 1.389, or 38888, and so on. On your unit circle, is there a place where sine is bigger than 1? No. This one's no solution. The biggest value you have for sine would be 1, right? So right here, this is where sine is equal to 1. It can't be bigger. All right, but what if sine is equal to 0.85? So sine can equal 0.85, right? That's 2 locations on our unit circle. What 2 quadrants? Where can sine be positive? 1 and 2, right? So when I do inverse sine, my calculator is going to give me one of those. I need to use math to figure out the other one. So when I do inverse sine, I got theta is equal to 1.016. That's this arc length, 1.016. Yeah, Kenzie? Yeah, so that's a negative, but it's still the same thing. It's still no solution. Yeah, thank you. All right, so how do I find the other one now? I don't do 2 pi minus the answer. Yeah, it's pi minus. Do you guys see why it's pi minus? So this one's going to be pi minus 1.016. So I get 2.126. So those are my 2 answers. Okay. It depends on where you're located. So if I had something like tangent, sometimes I have tangent answers, and I have one here and I have one here. If I got this answer was like 0.351, how would I get the one that's over here? Guys, think about it. You would add pi to it. You do pi plus the 0.351. Colton, get off your phone. Do you guys see what we're saying? Yeah.
So, like, I understand when it's positive or negative what quadrant goes in, but I don't understand, like, where to draw the line.
Like the first 2 lines?
Yeah.
Okay, so she's saying she doesn't understand where to draw the line. So everybody look up here. So what if I had sine of my angle equals negative 0.51? Where would my 2 lines be? What 2 quadrants? Yeah, 3 and 4. So here and here, right? Does that make sense? What if I had tangent? Tangent would be hard, right? What if I had tangent was equal to a positive number? First and third, right? Does it make sense? What if I said cosine was equal to negative? What 2 quadrants? 2 and 3, right?
So it doesn't really matter where the 2 lines go.
You can just put them in those quadrants somewhere. Yeah, that's fine. Don't overthink it. All right, good? All right, let's stop there. All right, I'm going to give you guys some time to work on